Улыбаетесь.
Another one?
Все, начинаем.
Okay. Ready to start? So now imagine the following scene: a room, smaller, much smaller than this one, and the same number of people, more or less, packed. So people one on top of the other, and me on stage talking about Silverlight. They didn't invite me anymore to speak at that conference. It was the first edition of an extremely popular conference taking place in Norway, in the UK, and also Australia, United States. But I was the rock star at the first edition 10 years ago. And I was there because I was one of the few people in this industry to know enough about the second extremely powerful version of Silverlight. Silverlight was dismissed, was dropped only a few years later. Nobody never figured out why exactly. Post-mortem analysis of the fact may suggest that it was the result of a sort of an internal war at Microsoft, but there were also concrete reasons, business reasons for dropping Silverlight. And if that was the reason, that it was a great reason because it showed that there were a lot of vision in the people who dismissed actually Silverlight, no matter it was apparently a stupid move at the time it happened. But a number of things after that point, around 2011, happened that changed the way in which we perceive web and, in general, just applications today. Silverlight was an attempt to bring in the web, within the browser, frameworks for building line of business applications. So it was not simply a way to fight Flash, was not a way to give great multimedia. It was a way to just use C# or, in general, a serious language runtime within the browser, replacing JavaScript. But that didn't happen, as you know, because Microsoft dropped Silverlight, and Microsoft dropped Silverlight probably because the web mobile and the mobile space was growing up. And they realized that they should have been able to deliver Silverlight applications across all possible platforms, including Android, and that was a nightmare. Or they were simply not ready yet to do that, because in order to do that, in order to bring a serious language runtime in the browser, they first had to build a cross-platform infrastructure like .NET Core. So the reason why today I'm so happy and excited to present about ASP.NET Blazor is that Blazor has the title on says that you may have read on the brochure. The official title of the talk was Blazor, is it the C# Angular or the return of Silverlight? It's both things, because the two things actually converge. So Blazor, ASP.NET Blazor is a platform entirely based on ASP.NET Core 2.1. And even though today it is an experimental beta, probably even less than beta level framework, it has been announced at Microsoft Ignite a few weeks ago, last of September, that Blazor will make its debut official. The 1.0 version of Blazor will be part of ASP.NET Core 3.0, which is, as far as I know, slated to be delivered, to be shipped somewhere at some point in the next year. So it's only a few months ahead. Now, back to the technical side. What is that? What's that? It's a plain .NET standard library So a Blazor application is a plain .NET standard library that has a program main entry point, and the entire thing gets downloaded and runs within the browser. Which browser? Nearly all browsers that normal people use. Okay, what is the definition of normal people? All the people in this room. Okay, I'm an exception. I have no member of my family here, which I regret, but if there were any member of my family, my son, even my wife, they would have laughed at me because I'm still one of the few guys on this planet that uses Internet Explorer. Okay, so sometimes when I'm not testing Blazor applications, basically. Okay, so which browsers? Essentially, browsers released approximately in the past 12-15 months. So browsers that have built-in support for something called WebAssembly. Blazor doesn't work yet on mobile browsers because of the WebAssembly limitation. Whether this will change in the future, we don't know. But the solution is relatively simple. Bring WebAssembly support natively on mobile browsers, whether it's Safari, whether it's Android, whether it's this or that. So today is essentially something that runs only or primarily on the vast majority. Someone calculated that today it's nearly 70%, 70% of browsers that are able to run WebAssembly and then Blazor, even though on some older versions WebAssembly is supported but is disabled by default. So anyway, if the idea will prove to be successful, all these aspects will be resolved in some way. Now, WebAssembly. What is WebAssembly? It's a binary language that targets a virtual machine, a stack-based virtual machine. Not that I'm an expert personally of stack-based virtual machine, but Googling around, I come to the conclusion that a stack-based virtual machine is similar, very similar conceptually, architecturally to CLR and the Java virtual machine, but it's different, for example, from the Android Delvik virtual machine. That's it. Fact is that technically any programming language can be compiled to emit WebAssembly code, and in addition to C# that does that through the infrastructure of Blazor, another notable example of a high-level language that can be natively compiled to WebAssembly is JetBrains Kotlin. Only in the case of Blazor, so the comparison, C# versus Kotlin. Kotlin can be natively compiled, but C# needs to have the intermediation of the .NET runtime. And it's the .NET runtime that is compiled to and deployed to WebAssembly and then deployed to the browser. The source code you write, instead, including the libraries you refer, they are simply downloaded into the sandbox, in the Blazor sandbox, and then run as they would run in a non-Blazor, non-browser environment. In terms of security, running Blazor in the browser or running JavaScript is exactly the same thing, which is good and bad news at the same time. Personal perspective, it can be as secure as JavaScript or as unsecure as JavaScript. It's exactly the same level. This screen shows what happens. It has been taken from Fiddler or something like that, a tool like that. Shows the list of files that are served, downloaded actually, in the browser when you start up a Blazor application. As you can see, the part in white at the top just contains localhost, Bootstrap, jQuery. I still use jQuery, I'm sorry. Loading a GIF, and then there are Blazor.js, Mono.js, Mono WASM. WASM is the signature of WebAssembly, and then the favicon. So basically, the biggest download is Mono WASM, which is about 700 kilobytes, so not a huge number, and that is the current .NET runtime compiled to WebAssembly. Mono, because at the moment, at least, the stuff that is downloaded to WebAssembly that allows Blazor to run is a shrink-wrapped version of Mono adapted by Xamarin to WebAssembly. And then a couple of JS files to deliver information about the synchronization on how those things should be arranged. And then in blue, there is the part that represents your Blazor application. Blazor 0 is the assembly that wraps up the entire application, and everything else is any necessary library, whether system libraries like the Microsoft ASP.NET Core, Blazor browser, and the other one, and then the libraries, abstractions, dependency injection, core lib, that form the .NET framework, the core .NET framework you are going to work with. Once the Mono runtime is downloaded, it begins the download of the actual .NET assemblies that make up the application. The entire initialization may take something around 3 to 5 seconds. So it's not especially fast. Again, this number can be improved because of performance optimization, perhaps, but it remains the fact that something big has to be downloaded. Now, if you try to play with Blazor, you have to pay this tax of 3 to 5 seconds every single time you modify every single comma or dot or quote in your code. So if you're coming from a web development experience in which you modify your Blazor file or refresh or your HTML page or your CSS, you hit F5 and you see results, well, it's going to be painful. Really painful. But there is a way to, there is a flavor of Blazor applications, we'll see this later on today, that minimizes a little bit, just a little bit, this state of things. Because it takes a few seconds, there is in the standard Blazor template a section that is specifically dedicated, so there's an HTML file that you are invited to specifically fill out with any animation, any videos, any movie, any funny thing you want users to see until the application is loaded. Okay, now, before we get to see some code, components. When we think Angular, when we think React.js, so when we think of those frameworks and libraries that are particularly popular these days for building web solutions, sometimes with the excuse that we need to face incredible numbers of scalability, most of the time because it's a matter of fashion, it's a trend. You can still write serious professional applications using plain ASP.NET, and the fact that you need fluent behavior, AJAX updates doesn't mean you have necessarily use React or Angular. You can achieve the same even with jQuery on top of ASP.NET. So it's Angular has its good parts, React has its good parts, ASP.NET has its good parts. So it's a matter of deciding what is the best for you without blindly following buzzwords. But yet, in Angular and React, much more than in ASP.NET, there is the vision of components. Someone says that Angular is really component-based, React, sort of. Whatever is the real state of support of components, components are an irrelevant part of the current and future web. There is also the web component standard coming up from, at some point will come up from W3C. So component is a small chunk of HTML that more or less contains everything, including script and CSS, through which you organize your final view. In ASP.NET Core, we have something called tag helpers. Now, tag helpers technically are a different thing from web components, but actually, if you take a look at the code from Angular, or an Angular page where you have custom directives, or a React.js code where you have custom components, or an ASP.NET source code where you have tag helpers, you still find markup elements with a custom name and a custom syntax. Still markup, so made of elements and properties, and maybe internal templates. So, abstractly speaking, there is, even in ASP.NET Core natively, something that we can associate to the idea of web components. In Blazor, those components essentially use tag helpers technology for the underlying implementation, but look like components look in Angular. So it's a separate file with a name, and the name of that file can be used as a tag in the page that consumes that component, and then public properties declared on the component can be set via properties. This is essentially the way, the approach, the philosophy of building the UI of Blazor applications, and Razor is the language through which we express any user interface. CSS is outside, so a Blazor component is primarily made of HTML and C# code, so there is no JavaScript. You can interact, you can interoperate with JavaScript code, you can interoperate with the DOM in much the same way you did in Silverlight. If you remember, if you ever had the chance, the pain of working with Silverlight, you may remember that there was a separate layer of code called JavaScript interop that allowed you to invoke from C# JavaScript code and C# code from JavaScript. It's exactly the same thing that you can experience with Blazor. It's exactly the same kind of pain you can experience in Blazor. But in this way of defining components, CSS is out, in the sense that dealing with CSS is up to you. You can encapsulate in components, or you can take CSS out of components at the global level of the page. This is just a short view that shows what you can achieve. The UI is whatever you can obtain with HTML and CSS. In this case, I'm using Bootstrap. You can use Materialize or whatever other sort of graphic support you wish to have. Publishing a Blazor application is as easy as publishing any other ASP.NET Core application. From Visual Studio, the simplest thing is just publishing to folder and then just upload a copy or publish in some other way all the files there. to the final destination. In Blazor, there is underscore framework folder that contains all the compiled assemblies as well as Blazor and Mono runtime components, and the underscore framework folder with the entry point index HTML is found in a distribute folder. Okay, now let me switch to Visual Studio and show you something. I will start from the canonical Hello World, so the application that you can obtain once you install Visual Studio, at least update 15.7 and Core 2.1. You have something like this. It's an application, just a few web pages tied up together, and some code that runs to do simple operations. In particular, look, there was the loading message that stayed up for a couple of seconds. If I go here on the counter page, notice that shifting from this to this, if you use Fiddler or any other network monitoring tool, there is no request at all. It's not an it looks like an hyperlink. It's an hyperlink actually, but the navigation takes place inside of the page as it would be a single page application. Now, the interesting thing is that when I do something on this click me button, of course, yeah, as you can figure out, the number is updated, but again, there is no call, not even Ajax call made to the server, and the code that increases the counter is C# code. It's not JavaScript code. And third step, when I go on this fetch data, you see that some fake weather forecasts show up. The interesting thing is that now there is an interaction. There is something that takes place outside the realm, the boundaries of the browser window, because there is an external web API that is invoked and that returns a collection of JSON objects, each representing a weather forecast. So, in Blazor, in much the same way you would do in a mobile application or in an Angular application, you have a front end, completely standalone, completely isolated, okay, from the rest of the world, but like an island, it sits there, but it has bridges that connects the island to the mainland. And the island that can connect a Blazor island, the bridge that can connect a Blazor island to the mainland of the backend are HTTP, Web API calls. The Web API backend is just a Web API backend. So it means that there is no dependency whatsoever on a technology. So the backend can be PHP, can be Java, can be .NET, can be ASP.NET, can be whatever you want. Can be a REST service, can be a RPC service, it doesn't matter. As long as there is a way to make a call that can go over HTTP, or as long as there is a protocol that allows a web client to connect to the web point, it works, and Blazor can support that. Again, I like to say that this particular aspect makes a Blazor application standalone, isolated, but connectable to any backend, very similar conceptually to a mobile application. And like a mobile application, it can work to some extent offline, so you can, not that easy, but you know, because you have access to JavaScript, you can still access local storage and save information. You can implement any internal activity in the phone, on the because of Blazor, on the PC, without interacting with the server. Let's take a look at the code. As you can see, okay, the project is a classic ASP.NET Core project with a program C# and startup C#, plus there is this app.cshtml. Program CS has nothing special but a custom class to connect to the startup. It's called use Blazor startup instead of the canonical use startup, because something happens at that point that is in a way different. The startup class nearly has one line of code, nothing in configure services. In configure, there is the iBlazor application builder, which is a variation on the standard iApplication builder interface that you find in the canonical ASP.NET Core startup class. And on the app object, there is a call on a method add component of T, where T is app. This is a syntax that, according to the Microsoft documentation, is going to change to be simplified somewhere in the future. Consider that today Blazor is version 0.6, and since the official announcement and publish of the first build, which happened probably this spring, they progressed, releasing a new build every approximately 6 weeks. So I've seen since this summer 0.4, 0.5, and 0.6. I expect a 0.7 if the pace is maintained in the next 2 weeks. 1.0 is expected for next year. So what is the point of this app type? The app type is fundamentally this a reference to this C# file. Also this syntax, configuring this here is temporary, so something will change. And fundamentally, this app CSHTML file contains this router tag that points to the assembly that contains the Blazor logic. All these parts have to do fundamentally with how the .NET runtime compiled to WebAssembly and your application interact. So you can consider those things as part of the configuration. Now, let's take a look at the remaining folders we have here. There is the classic www root, there is a shared folder, and there is a pages folder. For reasons that honestly are well beyond me, all of the canonical examples you build through the templates in Visual Studio push the Razor Pages programming model. But all of my personal examples, for which I will share a GitHub repo if you want to try them, I use regular controllers, controller methods, and views. So again, Blazor is built on top of ASP.NET Core 2.1, and in ASP.NET Core 2.1 you can build up a user interface in 2 different ways, through Razor Pages and or controllers. Let's take a look at www root. There is this, there's a CSS folder. As you can see, there is an index HTML. Let's open this up. And index HTML, in addition to linking any necessary script, if you have scripts, not in this case, and more importantly CSS, whatever it is, Materialize, Bootstrap, and so forth, has in the body, at the beginning of the body, this app tag. And whatever you put inside of the app tag is what will be displayed during the loading of the application. So you can put there a simple line of text, or you can put there an animated GIF, a video, whatever you like. And the app block disappears the moment in which the loading of the system is complete. And then there is this script tag that also does some internal work of linking some JS file. All these details of how, the name of the JS file, what it does, are subject to change. The fundamental thing is that app in this index file is the template of the entire, is the single page, okay, around which you build, is the template of the single page around which you build your application. Loading is any UI for the loading step, and whatever else you happen to have in this page, whatever any other sort of graphical stuff, H1, text, images, whatever, is going to be rendered after, so following at the bottom of whatever other UI your views will present. Let's take a look at some of the pages here. Let's take, for example, the counter page. Because it's a Razor page, it uses the page directive to define the navigation path, the route to this view. A little bit of HTML, button, and then you see the first weird thing. So imagine that, as you have seen during the few moments of the demo, I push a counter button and I increase a counter. Now imagine you would do that in a regular HTML page. It means that your button element will have an on-click handler where you increase a local variable. The pattern is exactly the same, except that instead of using JavaScript, we are doing everything through C#, and instead of the script tag, we have this new Razor style functions block. So there is this current count variable set to 0. There is an increment count function where we simply increment the counter, and the on-click attribute is connected with an expression that evaluates to C# code. Current count, the paragraph, just uses the canonical Razor syntax to show the content of a local variable. I invite you to take a look at the colors in this slide. In particular, the purple color for button and for on-click. If you ever practiced even a little bit with ASP.NET Core and manipulated or played with tag helpers, you know that the purple color is the color that Visual Studio uses to mark attributes and elements of a page, has tag helpers, so regular HTML tag with some attached logic, server-side logic, that changes the rendering of those elements. So it means fundamentally that the button element doesn't simply changes the way in which the markup is output for the on-click element. And in fact, the on-click element on the button HTML tag has to be the name of a JavaScript function. It is instead the name, a pointer to an expression that evaluates in C# code. So I don't know exactly what, but something happens in the underlying tag helper to connect the click on the event to something that in the end turns out to execute the C# code. Let's take a look at another page. This is fetch data and the page with the weather forecasts. There is a table built with a classic canonical for each. Nothing fancy. So imagine, so if this were a regular server-side Razor, that would have been an list of weather forecasts and then a table with a for each to populate the table. Nothing different from that so far, but in the functions block, okay, we have code that in the body of onInitAsync, which is the page load event, connects to a remote endpoint. In this case, it's not really remote because it's still part of the same local application, but it's in the next example, it would be just an HTTP something. So it gets via JSON a string, turns this string into a collection of objects, and then an array of this weather forecast types is bound. This HTTP, the red here is simply because there is a broken support of IntelliSense at the moment in Visual Studio. This HTTP, however, is an instance of HTTP client, canonical HTTP client from .NET Core that has been injected using the HTTP nickname. Again, also this particular aspect is in no way different from regular ASP.NET Core programming. Okay, let me stop this and let me switch to another project. Now, I want to show you a more sophisticated example. Let me first run it to give you an idea of how it could work. The demo will show a type ahead component. So it's an example of a custom component you could write. So here is a custom initialization for the time it takes to reach the page and load everything. Fetch data. Fetch. Okay. So I type something in this text box, and I'm looking ahead for a count to select a country. Notice that whatever you see is, colorful, uses different styles, so it's not a standard drop down. I make a selection here and something following my selection refreshes the user interface. So the point I want to show is not that, oh, I can select the country and to see the flag, but is how I can create in the source code of this page, fetch data 1. This is the source code of the page. I have this type ahead 1 that has a mix of canonical HTML properties, attributes, style, for example, class, and a bunch of totally custom, completely custom elements like this URL, like a custom event on selection made, and then this T item. Now, type ahead 1 is a custom component whose source code belongs to a file client to a file shared. Yep. To a file I have somewhere in my Blazor client application. So type ahead 1, CSHTML is the source of a custom component, and I can use that component from within a view, a web view. Back to the page here. That's it. So this element has a bunch of properties. He has a template, an item template property, which essentially is used by the logic internal to the implementation of the component to define how I want to render every single element in the drop-down that has been selected as a hint for users to pick up. On selection made is a custom event, and this custom event fired by the component when an element in the drop-down is selected. And the show selection is a page, this page code, C# code, that reacts in some way. And in which way does it react? It sets a few internal variables, country map, country name, and country description, with information coming from country, and country item is the element being selected, which is the argument being passed across the event. Country map, country name, and country description are local variables, and these variables are then rendered data bound to specific elements of the HTML template that creates what the user will actually see. So underscore country map is the URL for the flag. Country name is just the plain text, and it's basic Razor data binding syntax. Markup string is the same as HTML row in canonical Razor programming. So when I want to avoid the HTML encoding of text, so through the cast to markup string, I'm saying, okay, the content of country description, treat it as if it were HTML, so reflect any bold, any HTML styling. The context in red within the template is a bug of the current IntelliSense support, but context is the name, okay, that identifies the element that is being used to populate the template. So it's the this object that of type country, okay, that we are using to populate the template. Let's take a look at the type ahead. So type ahead here, this is a component in Blazor. Type param is the piece of syntax through which we declare the generic type that in this particular case, because this is a templated component, so it's a component of T that will deal with a generic T type, and the T type is called the T item in the implementation of this method. Beyond that, there is a bunch of embedded CSS. So in this case, the component hides internally a number of CSS settings, in particular the size of the drop-down, the font weight, margins, and the background color of the highlight for the elements being selected in the drop-down. And then within this div tag, there is the user interface, an input element, bind. This is the syntax that reminds you, if you have familiarity with Knockout.js, you can find some mappings here, and it's not coincidental because one of the author of Knockout.js is on the team that is building Blazor these days. The fact that I have to deal with on blur is a way to work around a current bug in the Blazor representation of the DOM. Instead of on blur, I would use probably on input. But on input doesn't work, okay, at this stage. And anyway, when there is this on blur or on event, so whenever the user types, I call try autocomplete, which is an internal C# piece of code. Here we go. So there is this function section, try autocomplete. It makes the call to the endpoint that will return hints. It receives data and populates the items collection, and then uses the items collection through the template. Okay, get a JSON here, perfect. Item template is rendered here. So notice that whenever a method here is called, at the end there is a call, a transparent call, the state, a notification throughout the internal DOM, state has changed, which reinforces the rebinding, the refresh of the user interface. So when try autocomplete runs, and items is populated, the entire chunk of HTML is refreshed, so the for each is run again, and item template is repopulated. To expose public properties or events out of a component, you just declare them in this function block using the parameter attribute. So selected, it now becomes something you can set from the caller as an attribute. Templates are declared as a parameter, and they are of type render fragment. And for the event, event is a parameter of type action of T, and T is the type that you return. And to fire the event on selection made, in this case, you just use a syntax like this, the invoke method on the property. So in the end, to cut a long story short, Blazor is a first attempt from Microsoft to offer developers something that builds on top of ASP.NET. So anybody with serious skills in ASP.NET, whether is core or even classic ASP.NET MVC in particular, can ramp up and build rich client-side applications running in the browser without having to go through a serious paradigm shift to embrace React.js or perhaps Angular. Now, this is pretty much everything. Just let me type out here the URL of my GitHub repo in case you want to take a look at all of these examples, prog core extras. Okay, so this is the place where you can find everything. There is another way that has been introduced recently to build Blazor applications. It's called server-side Blazor. Server-side Blazor is simply the fact that the entire code that in this demo runs through WebAssembly in the browser runs on the server. So there is something downloaded on the client, but it is a small piece. It's just the infrastructure downloaded on the client. So your app is not downloaded on the client, just the .NET runtime is downloaded on the client in the browser. So instead of 3 to 5 seconds, it takes much less. And everything runs on the server, but there is a WebSocket that via SignalR connects the server and the client. So whatever you do, whatever happens, whatever interaction is processed on the server, but its effects are visible, are transmitted on the client. So debugging is as if it were classic ASP.NET. Testing is easier. The cost at the moment is that every single interaction requires a round trip, but a round trip over a WebSocket. And a round trip that is binary, is not HTML, is not HTTP, is binary, so as fast as possible. But you have these two models to choose from. That's it. Thank you.
Thank you for your presentation. We have a time for questions.
There was one right here.
Thank you one more time. So just wonder, you said that almost all modern browsers are starting supporting WebDLL. So is it something they are preparing for Blazor, or is something else that probably was before Blazor, some technology which was working with this WebDLL, or Blazor is the first, or what is the history behind this?
WebAssembly is a W3C standard. I think it's not completely finished. The sequence of steps, it's not probably, it's a draft, I don't know exactly what. I don't know the stage of the, but WebAssembly is a W3C initiative. So it has nothing to do with Microsoft. Okay, Microsoft participates to the WebAssembly committee because Microsoft is a representative of Edge browser, and side by side with Chrome, good people from Google on the Chrome side, the Safari, and so forth. So it's a W3C effort, and it has nothing to do with Blazor. Blazor is simply an attempt to leverage WebAssembly, because the point here is that the architecture of browsers since the early days of Netscape has been that we support natively JavaScript, and this has never changed for compatibility reasons. Okay, JavaScript has been the only way for for the browser to open up its internal DOM to the world. But they, years and years ago, decided to offer an alternative scheme to bring into the browser some engine that could handle HTTP requests. And this was done through the mechanism of browser plugins. Explains why Adobe had to create their plugin, Microsoft had to create their plugin in order to run C# code, and Adobe to run videos and so forth, and to run their own language, Action, whatever was the name of the Adobe Flash language. Today, WebAssembly, but starting about 18 months ago, newer versions of browsers started adding this WebAssembly support. But given the nature of WebAssembly, this means that if a piece of code in a given programming language can be compiled to WebAssembly, browsers all of a sudden, without plugins, can run it in a sandbox, in much the same way they can run JavaScript. So whatever can be compiled to WebAssembly now, from the browser perspective, is the same as JavaScript, except that it's compiled language. So what Microsoft has done is, we have spent a lot of money to buy Xamarin. Let's have these guys do something serious for us, okay? Beyond the Xamarin Forms and so forth. So they took an experiment of Xamarin, porting a version of Mono to WebAssembly, say, let's build up on top of this. And then you see the story. Okay?
One more questions?
1, 2, 3, 4, 5, 6, 7 questions I can count.
Thank you for presentation. You said about testing this application. What benefits it have for unit testing, rendering testing, or maybe
unit testing? No, be serious. Be serious. Don't do testing. No, there is nothing like at this time. There is nothing like unit testing. I mean, it's the part that is C# code. Is C# code for which you can run unit testing, but beyond that.
Okay, and another question about a component. Can I use another component in template for someone component? So I can use it, or it's impossible?
You mean third-party components? Or
can I use in template?
Okay.
Some
I think so, but I never tried that one because templates have been added 4 weeks ago. I assume so. I think so.
Okay, thank you.
Our time is over. Now we will have after party.
Okay, if, after me, only the party. Okay.
Okay, who wants?
Okay, okay, we'll see at the party anyway. Thank you.